If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Also, after watching this video, you may want to refer to some of the playlists that we have created for people who are interested in in-depth knowledge. These are the videos in the right sequence, which will give you thorough knowledge of the subject. Please share it with all others who might benefit. Let's get started.
All right, so here we begin to do the text pre-processing, and we'll keep it at a very basic level. Basically, just to give you a familiarity with what you've heard in theory is something that's doable in practice. So we'll take very simple examples and consider this to be one of your first learnings relative to natural language processing. We'll do all these steps taking simple examples, and at each step, you'll get complete clarity on what's being done. So to begin with, when we're dealing with text, it is recommended that we convert all our text to one case, and generally it is lowercase. But there are certain inbuilt methods by default available in Python which allow you to try different combinations of cases. So we are taking a string here which is input text where we have written hello world but in a weird way. We have mixed the upper and lower cases more inappropriately here. So let's see what we can do to fix this. So this is the input text. And we are saying let's store this as the lowercase text, which is another object that we are creating, where to the input text we are applying .lower method. Now this .lower does not require you to install a specific library. It comes there with the string methods in Python by default. It's ideally supposed to convert everything to lowercase. Similarly, as the name goes, when we apply .upper, it should cover everything to the uppercase. When we apply title, it is supposed to convert the text into title case, which means the first alphabet would be uppercase and everything else would be lowercase. So let's see what's the output like when we try all of these together. We already know what's the input string, still we are just printing it. We are printing the lowercase, uppercase, and title case. Let me just run this. All right, so here's the output. As you can see, the original string was like this. The lowercase string is all lowercase, the uppercase string is all uppercase, and title case has the first alphabet of the word in uppercase, everything else in lowercase. That's what it does, right? Second is we may want to remove some unwanted patterns. And it's not just applicable to the pure text kind of data. It may be applicable with a typical structured data as well at times, where you have certain columns with certain patterns that you do not want. And as a result of those patterns being present in your data, you may be seeing the variables assigned to a different data type. A numerical column might be seen as an object because of the presence of some special characters or alphabets in it. So let's see how we deal with eliminating some unwanted patterns. We're not taking the structured data here. We're taking a simple text example called text1, which says, check out this website, and there's a web address that's given. Then there is some hashtag and some @ information is also there. So what we are calling here is the sub method from the regular expressions library. And we are mentioning the raw string. So this lowercase r essentially refers to the raw string, which is in general looking for a pattern, which is HTTP followed by a non-space character. So if you have a backslash lowercase s, that represents a space character. But if you have a backslash uppercase s, that represents a non-space character, non-white space character. And this plus here indicates one or more occurrences. So anything that follows after HTTP, which is not a space character, could have one or more occurrences, which means not just this particular link. If you come across a scenario where there is some other website that's mentioned, you can also eliminate that. And where are we searching this pattern? We are searching it in our text1, which is the input. So let's just run this and see what we get as an output. If you see, this has eliminated this entire thing followed by HTTP, but it was only looking for the non-space characters, which means the moment it encountered the first space, after this .com thing, there's first space that it encountered, it did not eliminate that. So it only worked up to the point where we did not encounter a space. If you notice here, there seems to be an extra space here. Why? Because there was a space here. Of course, a pattern didn't search for that space in the beginning. So that space plus this space at the end of the HTTP link. These two spaces put together seem to have put an extra space. So we'll see how we want to address that as well. So let's say in this string, we want to now eliminate everything other than alphabets and spaces. So what we're doing, again, there is a pattern for that. So we are again using the sub method from the regular expressions library. And the raw string pattern that we are looking for is not a lowercase alphabet or uppercase alphabet or a space. So in this string, whatever is not an alphabet, either lowercase or uppercase or a space, would essentially be eliminated. By doing what? This is the pattern. We are replacing it with a blank. So this is not a space here. You have two quotes here, but there is no space in between. This replacement is being performed on the cleaned text string that we got here as the output. Let's see what happens when we do this. So if you see this hash, this @, the numbers 1, 2, 3, all have been eliminated here. We still have an extra space as we earlier saw because we didn't do anything to the space. We said we only want to eliminate whatever is not an alphabet, uppercase or lowercase, or a space. So spaces and alphabets have not been touched. Everything else has been replaced with a blank. Now, if you say you want to fix this extra space here as well, what you can do is you can do another sub-method which says raw string would look for the presence of one or more spaces and will replace it with a space. This time, this is actually a single space. So if it is one space to begin with, we'll replace it with a space. That doesn't matter. But if you have multiple spaces, like the way we have two spaces here in the string above, you would be able to replace them with just a single space. And that should look a little neater. So here's the output. It says, check out this website, NLP. Might not be a grammatically correct sentence, but we are just saying that we are performing certain pattern checks on a specific text. Let's talk about eliminating specific patterns from our search. And once again, we have a pattern, which is a text. And this is related to maybe the platforms like X, where you would often see a lot of retweets, names being mentioned, hashtags being mentioned. Maybe what you're interested in is just the core message. You just want to see, click on this link, and what is the link? So you want to eliminate this RT, this @, and all the hashtags. That's what you want to do. So there are multiple patterns that we want to eliminate, and we want to do it together. So we are creating a list of the patterns that we want to get rid of. So we, of course, don't want this RT. We don't want anything that starts with an @ and it's not a space. So this caret symbol inside these square brackets represents not. And then we have \s, which represents the space. So we are saying whatever is not a space that follows @, it's one or more occurrences. This plus sign represents one or more occurrences. This is something that we are capturing as a pattern. Then we have another raw string which starts with hash, and it is something which is a word character. So word characters are numbers, alphabets, and underscores. We again have a plus sign, which means one or more occurrences of the word characters. It could be alphanumeric, it could be underscore, it could be an alphabet itself. That's again a pattern that we are looking for. So we have created a list of the patterns that we desire to eliminate, and we are storing this text as clean text here, just as an object. And we are saying for each pattern in patterns to eliminate, which means we are iterating over this list. And then we are saying is apply the sub method where the pattern will be picked up one at a time. The first time for this for loop, it will pick RT. It will eliminate that on the clean text by replacing the RT with a blank. This is a blank. There's no space here. Then the clean text has already been overwritten. Once again in the for loop, it will come back. You've already got rid of RT, and now you would look for the second pattern. Second pattern is this @ thing, so it will eliminate John. And then again, the clean text would be overwritten. It will be without RT and @. Finally, it would look for these hashtags, and it will eliminate that as well. Notice one thing here. In this particular case, when you eliminate RT and this @John, it would leave a space here to begin with. And then again, you would get rid of this @John : there would be an additional space. So this would leave a couple of spaces to begin with. In the previous example, we talked about eliminating additional spaces in between. We said if we encounter one or more occurrences of space, replace that with a space. That works, but that's going to work for the spaces that you encounter in between. If you want to eliminate the leading or trailing spaces, in this case, we are getting some leading extra spaces. What you can do is you can do a dot strip method. This again is something that's readily available. You don't need a specific library for this. It eliminates the leading or trailing spaces. Let's just run this and see what is the output that we get. So if you see, it says click on this link, https://example.com. That's what we're getting. Notice that in our codes, we have written import the regular expression library again and again, but it's not that you have to do. It may be that you're watching a specific video and you want to follow a particular syntax. So we've just mentioned it here. It's not that you need to do it again and again. The same code that you saw earlier through a for loop can be written in a more concise manner. And what are we doing here? We're calling it again the text tool, exact same text. We have mentioned a combined pattern using these pipes. So these pipe symbols that you see here are used as OR. So what we are saying is the pattern that we are looking for is RT or something that begins with an @ or something that begins with a hash. And then we are directly applying that using re.sub. We are saying this is the combined pattern. Whenever we encounter that, we'll replace it with a blank in text2. And then finally, we are again eliminating the extra spaces in between and the leading or trailing white spaces. So this will give you the exact same output that you got earlier. But if you think this is more concise because you didn't have to write a loop here, you may follow this. Next, we'll be talking about tokenization.